All right, let's finish up on test review worksheet number 3, chapter 4, test review. This problem does require a calculator for us to find many of these values. So an object moving along the horizontal line has the velocity function given by 4 sine of t squared minus 2t plus 2, measured in meters per second from time values from 0 to 4. And we're going to set windows to this between for x values from -1 to 5 and y values from -6 to 6. Okay, so these window values are given to you as a way to kind of help you see the graph a little bit better, but on the test you're going to have to adjust these on your own, find these on your own to get the optimal viewing window. Also, make sure that we round our answers to 3 decimal places. So part A, find the time when the object is motionless. So since we're looking at the velocity function, basically whenever the velocity function crosses the axis, that will indicate when velocity is 0 or when this object is motionless. So in your calculator, you can plug in y sub 1, first of all, as the given function, 4 sine of x squared minus 2x plus 2. Okay, we can set the window, minimum x value, -1 and 5, and minimum y value from -6 to +6. Go ahead and hit graph. Okay, let me delete the second graph here. Okay. So when we look at the graph, we see that there's going to be 3 intercepts. Okay, so these 3 intercepts here, this one is outside of our region, so we're not going to include this. So the way we find these intercepts, we can simply go to second trace, use the 0 feature, and we see that it'll be between x values of 2 and 3. So left bound 2, right bound 3. So my first intercept will be at 2.463, and I can repeat that same method for in finding the second and third intercepts. Okay. We can also determine the direction by where the graph is. So velocity function, this portion is above the axis, so we know positive velocity means that this object is moving to the right. Okay. Negative velocity, object moves to the left. Positive velocity, object moves to the right. And then finally, negative velocity, objects moving to the left. So we can demonstrate that on the sine line. Okay. But we know that from what we found from the intercepts that our object is motionless, velocity is 0 at these time values because v of t is equal to 0. Okay. Part B, when is the object changing directions? So we're going to get the same answer from part A simply because these values also have a change in signs, change in directions. But the reason now is because v of t changes signs, okay, at these times. Part C, find the velocity of the object at t is equal to 3 seconds. Now we know that we've plugged the velocity function into our calculator, which we are holding that information as y sub 1. So if you go to your home screen, you can click on vars, scroll over to yvars, function y sub 1, and y sub 1 holds the velocity function, so we can simply ask the calculator to evaluate 3, plug 3 into the velocity function to give us the velocity at that moment in time, which is -3.836 meters per second. Okay, part D, find the acceleration of the object at t is equal to 3 seconds. So we know that acceleration is the derivative of velocity. So we can simply use the calculator to find that information for us. We can call it the n-deriv. You can, in the calculator, go to Math 8, call the n-deriv feature. Y sub 1 will hold the velocity function. X is the variable. And 3 is the value that we want to the value we want to evaluate. So plug 3 into this will plug 3 into the acceleration function, which will give us 4.539 meters per second squared. Okay, part E is the object speed increasing or decreasing. So the way we determine increasing and decreasing speed is we compare the signs between velocity and acceleration. So velocity is a negative value. Acceleration is a positive value. So therefore, because speed is decreasing, because we have negative velocity and positive acceleration, and when we have opposite signs, that will indicate that we're going to have decreasing speed. Okay, part F, find the total displacement of the object from 0 to 4 seconds. So we can simply plug this in the calculator. Definite integral of velocity from 0 to 4. So in your calculator, you can go to Math 9, which will then get you to the Fn integral feature. Y sub 1 holds the velocity function. X is the variable. 0 is the lower bound, and 4 is the upper bound. Plug this in your calculator, and you'll get 7.753 meters. Okay, next part. Find the total distance of the object from 0 to 4 seconds. Very similar to what we did for part F, it's just that now we're going to put absolute value bars around the V of t. So the way you do that, you can go to Math, scroll over to Number, and the first option is ABS, the absolute value bar, around the Y sub 1. Okay, then we can have the calculator evaluate that for us, and we're going to get 12.178 meters. Part H, find the time when the object reaches minimum velocity in the time interval from 0 to 3. So again, if we look at the graph, we see that the minimum velocity between 0 and 3 will be at this point there. All right. So the way we can find that, we can go to second trace, use the minimum feature, third option down. We know this value is going to be between x values of 2 and 3. Hit enter twice, and we're going to get 3.927 seconds. And the y value is -4, so -4 will be the minimum velocity at that moment in time. Part J, find, given x sub 0 is equal to 2, find x sub 4. So if we want to find the position at x sub 4, we first need to identify a starting point, which is given to us, x sub 0, plus the definite integral from 0 to 4. This will give us the displacement from our starting point. So we found this from part F is 7.753. So 2 initial starting point plus displacement 7.753 will give us our final position of at 4 seconds being 9.753. Okay. Next part, find the average velocity in the time interval from 0 to 4. So average value theorem we know is 1 over b minus a times the integral of v of t from a to b. A value is 0, b value is 4, so we plug that in. We know the definite integral of v of t from 0 to 4. From part F again, 7.753, 1 over 4 times 7.753 will give us 1.938 meters per second. This is our average velocity. Essentially, it is displacement divided by the width will give us our height, and the height in this case is average velocity. Okay, last part here, find the times when the object reaches average velocity. So we can simply do this by setting the original function equal to the average velocity. In our calculator, we can graph this by subtracting 1.38 from both sides. So plug all this into the calculator, and when you graph it, you can simply look to see where it crosses the axis. Okay. So I have it entered in to the calculator as 4 sine, the second one here under y sub 2, 4 sine of x squared minus 2x plus 2 minus 1.938. All right, so we're going to graph it and look for the intercepts, because this will indicate where this object reaches average velocity. So we see intercepts at this 3 intercepts between 0 and 4. So again, we use the 0 feature. Okay, we see that this value will be between 2 and 3. So left bound 2, right bound 3. And we're going to get 2.279. So that'll be the first intercept. And we repeat the same steps to find our second and third intercepts, which is at 3.406 and then at 3.814 seconds.